Objective Petrology, multiple choice questions with answers. These are the collection from various previous years question papers, and I hope these are useful for various competitive exams like CSIR, NET, GATE, GSI and other exams. Welcome to set 17. Coming to the first question. Lime silicate rocks rich in iron silicates and are formed due to pyrometamorphism are known as. Choices are A. Scans, B. Tactites, C. Tektites, D. Condolites. So the correct answer is scans. Scans are tactites, or these are coarse-grained metamorphic rocks that form by the replacement of carbonate-bearing rocks during regional or contact metamorphism and metasomatism. And these scans may form by metamorphic recrystallization of impure carbonate protoliths, and also by metasomatic reaction of different lithologies and infiltration metasomatism by magmatic and hydrothermal fluids. So the correct answer is scans. These are the lime silicate rocks rich in iron silicates and are formed due to pyrometamorphism. Next question. Rocks which have been completely pulverized and rolled out by extreme differential moment are. The choices are A. Crushed breccia, B. Mylonite, C. Cataclysite, D. None of the above. So the correct answer is B. Mylonite. Mylonite is a fine-grained, compact metamorphic rock which is produced by dynamic recrystallization of the constituent minerals, resulting in the reduction of the grain size of the rock. And these mylonites can have different mineralogical compositions, and it's a classification based on the textural appearance of the rock. So it is a completely pulverized and rolled out by the differential crustal movements. So B. Mylonite is the correct option. Next question. Minerals with poorly developed faces are called A. Idioblastic, B. Pseudoblastic, C. Xenoblastic and D. None of the above. Minerals with poorly developed faces are known as xenoblastic. These are the minerals which are formed as a result of metamorphism. They may show well-developed faces, thereby exhibiting texture, are known as idioblastic, whereas the texture which is formed by the formation of minerals that do not have well-developed faces are known as a xenoblastic texture. So C. Xenoblastic texture is the correct answer. Next question. Structure typical of argillaceous rocks is A. Cataclastic, B. Maculose, C. Granulose, D. Schistose. The structure typical of argillaceous rocks is maculose. So maculose structure, it is characterized by spotted appearance of the rock, and this may be caused due to the formation of large size crystals, and these are also known as porphyroblasts within an otherwise fine-grained rock as a result of thermal metamorphism of argillaceous rocks like shale. So structural, that is a structure which is a typical of argillaceous rocks is maculose. B is the correct option. Next question. Which structure is developed largely in rocks with granoblastic minerals like quartz, feldspar, garnet? So the choices are A. Maculose, B. Cataclastic, C. Granulose and D. Schistose. So the correct option is granulose. So granulose structure is a typical structure of the metamorphic rocks like marble and quartzite, and this is characterized by essentially granular character of the constituent minerals. And granoblastic texture is typical of the quartzite, marble, charnokites and other non-foliated metamorphic rocks without porphyroblast. And these characteristics defining granoblastic texture include the grains which are visible to the unaided eye, and structured or known as the sutured boundaries and approximately equidimensional grains. So the structure which is developed largely in rocks with granoblastic minerals like quartz, feldspar and garnet is known as a granulose texture, granulose structure. So C is the correct option. Next question. Which structure is common in quartzo-feldspathic rocks? A. Gneiss, B. Cataclastic, C. Maculose and D. Schistose. The structure common in quartzo-feldspathic rocks is gneiss. So gneiss rocks are largely coarse grained, and gneiss, it exhibits a gneiss structure, and quartz, feldspars, mica and amphiboles with alternate light and dark colored bands, they give rise to the gneissic bands. The structure common in quartzo-feldspathic rocks is gneiss. Next question. Composite structure with alteration of foliate and non-foliated sands and lenticels is known as A. Maculose, B. Gneiss, C. Schistose and D. Cataclastic. So the correct option is gneiss. So gneiss structure, it shows discontinuous banding of light colored medium to coarse grained minerals such as quartz and feldspar, and dark colored minerals such as pyroxene and hornblende with granulose texture. So the composite structure with alteration of foliate and non-foliated sands is known as a gneiss. B is the correct option. Next question. Texture with sugary appearance and seen in marbles and quartzites is A. maculose, B. cataclastic, C. saccharoidal, and D. schistose. So the structure with sugary appearance and is seen in marbles and quartzites is known as saccharoidal. This texture is commonly found in rocks such as marbles, quartzites, and foliated marble. It displays typically a sugary texture. This is known as a saccharoidal texture. C is the correct option. Next question. Uppermost zone that is characterized by mechanical and chemical metamorphism of hydrosilicates is A. Mesozone, B. Epizone, C. Catazone, and D. None of the above. So the uppermost zone that is characterized by mechanical and chemical metamorphism of hydrosilicates is known as epizone. This term epizone, it was originally proposed by the Grubenman in 1904 to indicate shallow depth of metamorphism. And the epizone lies near the Earth's crustal surface where the temperature is low. Approximately this is around 300 degrees centigrade and directed pressure is high. So B. epizone is the correct option. Next question. The lowermost zone characterized by long continued chemical crystallization with deformation is A. epizone, B. mesozone, C. catazone, and D. all of the above. The lowermost zone which is characterized by long continued chemical crystallization with deformation is known as a catazone. So according to the Grubenman's classification of metamorphic rocks, the lowermost depth zone of the metamorphism is known as a catazone, and this is characterized by high temperatures. It is roughly around about 500 to 700 degrees centigrade, and this is mostly it exhibits strong hydrostatic pressure and low or no shearing stress. So this zone is known as a catazone. C is the correct option. Next question. Spot the odd one out. A. biotite, B. muscovite, C. starrolite, and D. cerussite. So the correct option is D. cerussite. Why? Because the other minerals like biotite, muscovite, and starrolite, these minerals belongs to the catazone, while cerussite it belongs to epizone. So D is the correct option. Next question. Richest stress minerals are found in A. The choices are A. epizone, B. mesozone, C. catazone, and D. none of the above. So richest stress minerals are found in mesozone. B is the correct option. Next question. Hornfelses generally possess A. porphyroblastic fabric, B. granoblastic fabric, C. a combination of both porphyroblastic and granoblastic fabric, and D. foliated fabric. So hornfels generally possess both the combination of the porphyroblastic and granoblastic fabric. C is the correct option. Next question. The metamorphism, including the combined effect of uniform pressure and heat, is described as A. plutonic metamorphism, B. dynamothermal metamorphism, C. cataclastic metamorphism, and D. contact metamorphism. So the metamorphism, including the combined effect of uniform pressure and heat, is described as plutonic metamorphism. By plutonic metamorphism, it is meant that the changes are produced in the rocks by great heat and uniform pressure, and these changes necessarily takes place in the catazone according to the Grubenman, at depths where the directed pressure becomes less and less pronounced, and finally it becomes a practically negligible factor in the metamorphism. So the correct option is A. plutonic metamorphism. Next question. With the increase in the grade of the metamorphism, the anorthite content in the plagioclase A. increases, B. decreases, C. either increases or decreases, D. not altered. With increase in the grade of the metamorphism, the anorthite content in the plagioclase increases. A is the correct option. So the anorthite content of the plagioclase increases with the increasing grade of the metamorphism in the basic rocks and the calcareous rocks, and the facies concept was proposed by Escola in 1939. So with the increase in the grade of the metamorphism, the anorthite content in the plagioclase increases. A is the correct option. Next question. The most common garnet of gneiss and schistose rocks is A. almandine, B. pyrope, C. grassolerite, and D. andradine. So the most common garnet of gneiss and schistose is almandine. So the almandine pyrope rich garnets, these are very common in large areas of the high grade gneissic regions. So A. almandine is the correct option. Next question. Which of the following minerals is stable at low pressures? A. wollastonite, B. grassolerite, C. vesuvianite, and D. none of the above. So the minerals which is stable at low pressures is not, it's not A or B or C. So it's none of the above. It's wollastonite or grassolerite and vesuvianite. These are not stable at low pressures. Next question. The pyroxene that is characteristic of the rocks belonging to the Charnockite series is A. Diapsite, B. Hypersthene, C. Enstatite, D. Omphacite. So the pyroxene that is characteristic of the rocks belonging to the Charnockite series is known as hypersthene, and these Charnockites are dark and greasy looking rocks, and they are also grayish or greenish or bluish gray in color and equigranular in texture with a pleochroic that is known as orthopyroxene, and it is probably hypersthene. This is suspected at invariably, and this is found to be present in the Charnockite series. So B, hypersthene, is the correct option. Next question. Soapstone are the metasomatic products of A. Peridotites, B. Anarthosites, C. Spilites, D. Tholites. So soapstones are the metasomatic products of the peridotites. Peridotites, dunites and serpentines in this environment, they can be metamorphosed into soapstone. On a smaller scale, soapstone can form where siliceous dolestones are altered by hot and chemically active fluids in a process known as a metasomatism. So soapstones are the metasomatic products of peridotites. A is the correct option. Next question. Thermal metamorphism of calcareous rock within aluminous impurity give rise to A. Recrystallized limestone, B. Wollastonite, C. Anarthite, and D. Periclase. So thermal metamorphism of a calcareous rock within an aluminous impurity, it gives rise to anarthite, that is calcium aluminum silicate. Hope you have followed the important questions from petrology, and hope you can subscribe to this channel, Explore Geosciences. Thank you for your time. See you in the next video.